12b.2 is continuing to model with quadratic functions. And again, modeling is we are making an equation given data. So when we have more than 3 data points that suggest a quadratic function, you can use the quadratic regression feature of a graphing calculator to find a quadratic model of best fit. So go ahead and write that down, and then we're going to talk about some of that phrasing and some of those words and what that means. Okay, when we have more than 3 data points. So in the last section, we only had 3. We were able to use the systems of equations to find our model. Now we're going to be given more than 3. That suggests, so they won't perfectly form a quadratic. So it's not going to be exact. It's going to look like a parabola, but one point might be a little bit off. We can use the quadratic regression feature of a graphing calculator. We're going to be using Desmos to find a quadratic model of best fit. Best fit, again, this is not exact. It's an approximation. Because a graph, one of our graphs, could look like we have points and this one's like a little off. So we kind of have like a curve here and that one's just a little off. Or we could have something like this, to where it looks like a parabola, but not all the points are going to be exactly on our model of best fit. We're going to be using our standard form again, so just a reminder, that's y equals ax squared plus bx plus c. And our calculator will find a and b for us. So our first example is just going to be a little practice with Desmos. I found a video on YouTube that kind of walks you through how to use the quadratic regression on Desmos. So go ahead and write down this table of values because this is going to be the data that you're going to be using for that video. And then go ahead and pause this video and go to the quadratic regression Desmos video on YouTube to show how to use the quadratic regression stuff on Desmos. Watching that video, I know that we got negative 0.3047 x squared, y equals plus 1.3966x plus 19.0415. From that data, this was our A, B, C. And just to note, our R squared was 0.9965. And again, this was our percent of data explained by the model, and that is very high. So 99% of the data plus 99.7% was explained by the model. Here's our next example. Go ahead and write it down. This piece says time in our table. You might want to pause the video so that they can have more time to write it down. Now that you've written it down, the table shows the meteorologist's predicted temperatures for a summer day in Colorado. So here's our table. I noticed that my time is an actual time. We're not going to be able to just plug that straight into Desmos, so we're going to have to think about how we can represent those numbers. Let's look at our questions first, though. What is a quadratic model for this data? So we're going to find our equation. Predict the high temperature for the day. So we have to find the highest temperature. And at what time does the high occur? So let's go ahead and look at our data. We have 6 a.m., 9 a.m., 12 p.m., 3 p.m., 6 p.m., and 9 p.m. So I'm going to represent 6 a.m. as 0. And so that means 9, that's 3 hours later. So that's going to be 3. 12 is 6. Another 3 is 9, 12, 15. So instead of 6, we're going to do 0. 9 is 3. And add 3 for each time. Let's go ahead and type this into Desmos. So we add our table. And I have 0, 3, 6, 9, 12. Oh, it guessed it for me. 15. Cool. That's nice. 63, 76, 86, 89, 85, 76. Okay, so we typed in our data. Make sure you always double check to make sure you typed it in correctly. And now let's kind of look at our data. There it is. On your computer, if it's not touchscreen, you'll probably have to use the options, the wrench to change your steps. Right here for the x-axis and the y-axis to change your range. Now we type in our regression model. And remember for the regression model, this says y1. We want to pull these numbers, so we have to type in y, and this a sub b is how I get a little subscript, the a sub b button, 1. And then I want to arrow out of the subscript, so I'm going to push this arrow over. Now, I'm not going to put equals because we don't necessarily equal exactly. We're approximating. So go to your ABC, and here's your approximating. And then we have A times, go back to your ABC, X, do a subscript. We need a 1 because our values are pulling from the X1. We need to arrow out because we need to make that squared. So that's where I'm at now. If you have questions, please ask your classmates to help you. Then I'm going to add B times, again, X. We want the subscript 1. We want to arrow out of the subscript because then I want to add C. And notice that adding C really made it to where we can see that it connects. And we see that it mostly touches all the dots except for that first one, so that's why this is a line of it. So let's look at our model. Our R squared is 0.996. That's pretty good, 99.6. Our A is negative 0.3294. Our B is 5.845, and our C is 62.5. So let's go ahead and write those down. So we're on question A. And A, we're going to do 4 decimals, 0.3294. B, 5.8452. And C, they only give us 1 decimal, so we're just going to use 1. So our final answer is y equals negative 0.3294 x squared plus 5.8452 x plus 62.5. Now, I want us to write down, let's go ahead and write it under A, what we typed in to find that. So we typed y1, the little tilde for approximate, A times x1 squared plus B times x1 plus C. Okay, so for part B, predict the high temperature for the day. So high tells us that we're going to look for a maximum. Temperatures are y value, so we're going to find our y. We're in standard form. We're going to use negative b over 2a, so negative 5.8452 over 2 times negative 0.3294. And I got 8.87. So this is the hour to where we'll have our high. That's our x value. To find our y value, we need to plug it in. Y equals negative 0.3294 times 8.87 squared plus 5.452 times 8.87 plus 62.5. And you should get 88.5 degrees. Now looking at our table, we see that we have an 89 value. Yes, this is higher, but they asked us to predict. When we're asked to predict, that means we need to, this word predict tells us to use the model. Let's go ahead and look at C. At what time does the high occur? Time high. High means vertex. Time is our x. We already have that. That's at 8.87. And so this is going to be in between, let's look back. 3 is 9, so that's close to 9. So in between 2:30 p.m. and 3 p.m. We don't need to be exact because we're just predicting. But you do need to go from the 8.87 to a time because we were originally given our information in time. We will have one more example. This will be our last example. Go ahead and let the students write this down. Now that you've written it down, let's go ahead and read it together. A man throws a ball off the top of a building and records the height of the ball at different times. So we're given his time, and note that they're giving us the units in seconds, and then they're giving us the height of the ball, and that's in feet. We're going to find the quadratic model. Again, we're going to find the equation that best fits the data. Use that model to estimate the height of the ball at 2.5 seconds, and then find the maximum height of the ball. So let's go ahead and get out our Desmos. Now I want you to pay attention because some of you notice how I have added a table. I still have x1, y1. Some of you might have x2, y2. Pay attention to that because we'll need that later on. Go ahead and enter your data. We have 0, 1, 2, 3. Then I have 46, 63, 48, 1. Again, kind of look to see how your data is. We have a point there and a couple right there. So now we're going to add an expression. Well, let's just add one underneath. You can just tap underneath to add one. Now, I have y1 still, so I'm going to type y1. Some of you, though, might have a y2, so you're going to type y2. So go to your ABC, y subscript 1, arrow over. We use that little squiggle line. A times x1 arrow out squared plus b, make sure to hit that times x subscript 1. You have to put the x1s in. Arrow out. And again, some of you might have x2 up here. I still have x1. If you have x2 though, you need to be typing x2. plus b. And so here's our information. If we notice, our curve is hitting most of our points. And they gave us our letters. Our r squared is 1, so that means 100% of our values fit this line. So for A, we have A equals negative 16, B equals 33, C equals 46. So our model is y equals negative 16x squared plus 33x plus 46. Part B, use the model to estimate the height at 25 seconds, at 2.5 seconds. So this is telling us t equals 2.5. And since we want to estimate, we're going to use the model. So we're going to plug 2.5 in for our x. And if you wanted, you could have done y equals negative 6, or height, h equals negative 16t squared plus 33t plus 46. You can use different letters instead if you want. So t equals 2.5. So we're finding we're going to use the bottom one, or h and t. Height equals negative 16 times 2.5 squared plus 33 times 2.5 plus 46. Go ahead and plug that into your calculator. Plugging it in, I got 28.5 feet. So again, we just plugged in 2.5 to either x or our t. Part C, we're going to find the maximum height. So maximum tells us vertex. Height tells us our y or our h value, depending on which one you're looking at. We're in standard form. We're going to use our negative b over 2a, negative 33 over 2 times negative 16. I got 1.03125. Since there's not an infinite number of digits, I'm just going to write all of them down. Now we can plug that in. H equals negative 16 times 1.03125 squared plus 33 times 1.0125. Oh, I forgot a 3 in there. Plus 46. Let me write this number better. 0.1.03125. Type that into your calculator. And I get 63.02 feet. And that is looking at finding the maximum height based off of our model. If you looked in your picture, you might have guessed that the maximum happened at that point, right? One of our points. That 163, but it's actually this point. And if you notice, I was able to touch the vertex on the graph, and it gave me that point. But I do expect you to show your work on how you found it, because we just need to keep practicing how to find that vertex.